right, welcome. I'm going to be essentially demoing how to model a dice or some of the processes involved with modeling our dice and kind of demonstrate the workflow. And as I'm doing this, I'm going to be kind of narrating my thought process. Um, the dice that I'm going to make is not going to be the dice that is dimensionally called out on the technical drawing for this week's assignment, but we're going to be. But I just wanted to kind of demo the workflow about how I would approach a project like this. So, um, the very first thing that we're going to do is we are. I'm actually going to just start with a brand new file. And the very first thing I'm going to do is I'm going to create a new component. Remember that everything in Fusion 360 is organized in components. And I'm just going to call this dice. And you can see that our component showed up here in the left-hand corner. And now with it highlighted, with the little dot next to that, that's how we know we've highlighted this, we're going to create our first sketch inside of that object called dice. And I'm going to select the top plane, and then I'm going to hit the R key for the rectangle tool. You can also find the rectangle tool up in the upper left-hand corner here. So I want, so the reason that I choose the rectangle tool is because in CAD, and I'm going to, in CAD in general, we want to be as efficient as possible. And there's a lot of clicking in CAD anyways. So rather than using the line tool and clicking 4 times to create a box, I'm going to use the rectangle tool, click once, and type in these dimensions that we see floating on screen here. And I'm just going to say 25 and 25 here, just like that. And that is the that is the foundational sketch of the dice done. Now, um, the other thing that I can do here that's a workflow thing that you can do, we want to make 3D geometry from this sketch. And one of the things you can do in Fusion 360 is, if you guys remember from the tooltip, we can hit the E key as the shortcut or the hotkey for the extrusion tool. If we do that inside of a sketch like this, it'll jump us out automatically, and it will assume um, it will allow us to just move right into making our extrusion. I'm going to type in 25 at this icon box here, and I'm just going to double check and make sure that the type of extrusion we're doing is the solid body version, and we're going to create a new body down here. If this dialog box says anything else, make sure to change it to the extrude type, and the operation is new body. We're going to click OK. From there, I'm going to select the first face that we're going to be sketching on. So I'm going to left click, and then I'm going to grab the Create Sketch tool again. And now what's happened is by clicking on that face and clicking the Create Sketch tool, we can, we have created a sketch on this face, and Fusion 360 has basically snapped us to that. And so like if I orbit around the object now real quick, you can see that our sketch plane is actually resting right on the surface of the face of the cube that we selected. I'm going to go over here and click on the highlighted top portion of the cube in the upper right hand corner, and that will just snap us back to the top view so that we can sketch, so we can look down on our sketch perfectly. From here, we're going to go through the process of creating the first divot on one face of our dice, or the first pip on one face of our dice. And the way that I'm going to approach this first one is that we're going to highlight the line tool. I'm going to hit X for, or I'm going to activate the line tool with L, and then I'm going to hit the hotkey X to activate construction geometry. And then I'm going to mouse across the top of this line here. And until we see the X and the triangle both um, popping up next to my cursor. That triangle indicates that you're at the center point of whatever line segment you're tracing against. And from there, I'm going to click. Whoops, I missed my mouse. So we're going to do that one more time. And now I'm going to come back down and I'm going to find the triangle again on the opposite side. And this is, and you can see that we have this triangle symbol here, here and here. This is a constraint, which is called the center point constraint, that Fusion automatically adds, or excuse me, midpoint, not center point. I'm using SolidWorks terminology. So this is the midpoint constraint that Fusion 360 automatically will add when you use that technique of finding the center line. We're going to do the exact same operation one more time, but on the opposite direction, just like this. So we have this cross, and this is going to directly identify the center of this square. And from there, I'm going to grab our circle tool, and the hotkey for the circle tool in sketch mode is C. So I'm going to hit C, and then I'm going to just go to the center there, and I'm going to draw a circle. Now, the first thing that we want to do here with this circle is we're actually going to use this circle to create three-dimensional geometry. So this cannot be a construction geometry. So we're going to highlight our circle, hit X to make sure that it's a solid line. And then from there, we're going to grab our dimension tool up in the upper left-hand corner, or you can use the hotkey D. And I'm going to grab that, and I'm going to provide a dimension, and I'm going to say that this is, we'll say this is a 1 millimeter. 1 millimeter looks a little small. Let's actually bump that up to like 3.5. I think that's a good size for this demonstration. So now we're going to, the way we're going to use or create this pip, or the strategy I'm going to employ here, is I'm going to use the revolve tool to basically scoop out a divot in the surface of the cube to make the pip on this side of the dice. So to do that, I am going to grab our line tool one more time. I'm going to trace from the center point up to the top, like so. And then I'm going to click and drag back here up, and you can see that my line is still a construction line. So I'm going to hit escape real quick, and I'm going to turn off construction geometry. And now with the line tool active again, we're going to draw that line from the top to the bottom. And now we should have two halves of this sphere. From there, I'm going to grab our trim tool, which is going to let us basically delete line segments where they intersect either construction geometry or actual solid line segments. And I'm just going to click on the line segments that I don't need, so that I have essentially a half moon shape or half of this circle. From here, we are ready to perform the revolve operation. So I'm going to click Finish Sketch. I'm going to give it a minute to think. We're going to activate the revolve tool in the upper left-hand corner there. And now we're going to, here we have our revolve dialog box. The first thing we need to provide is the profile that we're going to revolve or use to create geometry. So we're going to select on the inside of that circle. And then we're going to select an axis. And the axis we select is going to be that solid line that calls out half of that circle. And from there, we are going to we should see a red preview. If you don't see a red preview and you see like a solid orb that's like sticking out of the surface of the cube or something like that, come down here to the operation drop down menu in the revolve dialog box and make sure you have cut selected as the operation to perform. And then once you do that, we click OK. And then we will and then once that operation is done with, we will have we have our divot, our first divot on our on the surface of our dice. So now, so that's one side of our dice done. Now let's go and find, let's do another side of our dice. So I'm going to go over here, click the opposite side, and I'm going to create another sketch. And now this side, we're going to use 2 pips. And on a dice, 2 pips are always kind of diagonally across from each other, right? So the strategy that I'm actually going to employ here is that we're going to use construction geometry, or we can do 2 things that we can set up here. We can use a rectangle as construction geometry to create 2 points for us to create pips from. But the other way that I would actually the other strategy I would employ here in this circumstance is that I would actually use the offset tool. And what the offset tool does is it basically, we select a bunch of line segments like this, and it will create an offset, but we can flip the direction that these line segments get created, and we can increase the number of or the offset distance from the original profile that we selected. One thing to note with the offset tool is that if you select the outer, like one of the outer line segments of the cube, and it doesn't automatically select all of the other ones, you can click the chain selection dialog box, and that will select all of the line segments that are connected to each other in a continuous chain. And then from there we click OK. Now we're not going to use this construction or this box to create any geometry. So we're going to go over here and highlight that box and click construction geometry so that we have the dashed lines here. And then we're going to use these 2 points here and here as the reference point for the center of our circles so that we can make those pips. So here, I'm just going to draw a circle. And the other one we made was 3.5 millimeters. So I'm just going to use the exact same dimensions. And here, I'm going to show you a trick with the very first constraint that we're going to actively use. And this is the equals constraint right here in the upper kind of mid left. The equal constraint allows us to say that 2 objects or line segments or 2 pieces of geometry are exactly the same. And so if we click on one and then we click on the other with the equal constraint active, you can see that the size of this circle down here changed automatically, and it's now equal to this circle up here, which has a dimension of 3.5 millimeters in diameter. So now that we have both of these circles created, we're going to go through and use the line tool just like we did before on both circles. Then we're going to grab our trim tool. And And you'll notice that I got a warning here that a constraint or dimension was removed during this operation. You'll see that pop up from time to time again. In this circumstance, it doesn't matter too much. Later on, we'll want to be more cognizant of that warning when we're doing more complex modeling. But for now, we can pretty safely ignore it. So now that this sketch is essentially finished, I'm going to come back here. We're going to activate the revolve tool, and we are going to perform the exact same operation. Um, but we're going to do 2 revolves essentially because we have because we can only select one axis of a during a revolve operation at a time. So here, since these 2 spheres do not share the same axis in this circumstances, the way that I've set this up, we can it will be it'll have to be 2 revolve operations. There is a way that you can set these 2 to have this to share to be collinear on the same axis of revolution, but I'll leave you guys to think about that one and to see if you guys can figure out a strategy to do this in 1 revolve operation. But I'm going to demonstrate it twice just so that we can get the reps. So there's the first one, right? But our sketch disappeared, and we want to be able to see that again. So I'm actually going to pause here for just a moment. I'm having a technical difficulty with another piece of software. I'll be right back. All right, we're back. So what we can do is we can come back here and we can right click on the feature that we just created in the timeline, and we can either go back and edit this sketch again. Actually, no, that's not what we want to do. We want to make that sketch visible. So this is actually the first time we're going to interact with the drop-down menu. We're going to come down here. We're going to, on our dice object, we're going to left-click on that chevron to open up this drop-down menu. And then we're going to open up the sketch drop-down menu here. And we're going to highlight through these until we see our base level sketch here, and we're going to click the eye icon to make that sketch visible again. And now we can use the revolve tool again, and we can reselect that the other profile in that sketch, select the corresponding axis, and click OK. And now we can hide that. We can hide the pips, or not the pips. We can hide that base underlying sketch again, and we can now we have 2 faces of our dice complete. So the next one that I'm going to demonstrate, we're actually going to look at creating patterns with pips, and I'm going to demo a couple of the pattern tools and soft introduction to basic patterning of features and sketch geometry. So I think we're going to grab this face. We're going to start another sketch. And this time, we're going to find the center line. We're going to create construction geometry. So hotkey for the line tool is L. And to toggle construction geometry, you can hit the X hotkey, or you can select it from the sketch palette. And now what we're going to do is I'm going to grab our circle, and here I'm going to create our first rectangular pattern. And the pattern tool, I probably did that a little fast, so let me back up. To find the pattern tool, we're going to go up to the Create drop-down menu. And from there, we are going to come down to Rectangular Pattern. this dialog box is going to pop up, and it's asking us for two things: objects and directions. When we select our object, this dialog box is going to expand. And then when we select our direction, we need to select like a reference line to denote like an axis of movement. And so we can select horizontal axes of movement that move across the red line here, or we can select vertical axes of movement that move in parallel with the green axes here. I'm going to I'm going to use the construction geometry we made it as our axis, and we're going to. And you can see that as I drag this arrow, we start getting copies of that profile being made. But these are looking a bit large, so the first thing that I'm actually going to do before we finish creating this pattern is that I'm going to dimension this circle at 3.5 millimeters. And now we're actually going to go back and create our circular pattern. And so circular pattern, or not circular pattern, rectangular pattern. Okay, have some people bugging me on Discord. We're going to go there. Do not disturb. So, where was I? Rectangular pattern. So we're going to select the object that we're going to pattern, and then we're going to select the direction that we're going to pattern in, and we can move this direction either way. But ideally, we want this pattern to move in a symmetric manner. So if we go down in the dialog box to the direction drop-down menu, we can either have one direction or we can have the symmetric option, which will put an equal number of our patterns or an equal number of our quantity that is on either side of like the starting point of the pattern, essentially. And if we increase our quantities here, on this dialog box, I'm not sure why it's not updating with that one. But if we increase our quantity here, seem to be running into a bit of a graphical glitch here. We're going to reset some stuff real quick. I'm going to say 3. I'm going to go back to one direction. And it looks like we have, looks like a separate axis got accidentally selected there. I'm not sure what happened there, but this type of stuff happens when you're working with software like this. Sometimes things, sometimes there's a small glitch, or we make a selection. So I'm just exiting out of that pattern, restarting it. We're going to select our object one more time. We're going to select our direction this way, and we're going to select symmetric. And now we should be, there we go. We have our 3 pips here. If we hit enter at this point, it just recreates those. And you notice that all of them are defined because for a couple reasons here. First of all, we defined the diameter of these circles, so they're all the same size. So Fusion knows how big they are. We started this, we drew this initial circle that we are patterning off of in the exact center of this square. And then we have and then because this square is drawn directly off the origin point, Fusion knows how big is the square. It knows where the center of the square is. It knows that we have a circle at the center, and it knows that we've patterned a known distance away from these circles. So it has all of the information it needs in terms of the absolute location of all of those patterned circles, automatically from the way that we've laid out this sketch. And this is one of the things that that will make you more efficient in CAD. And it's one of the things to think about as like we move through the quarter. It takes practice to kind of intuitively understand like how all of this stuff works together. So if this is not making a whole lot of intuitive sense right now, don't worry. As we get repetitions on the software, this like we will exercise this kind of thinking muscle in this way, and this process will become a lot more intuitive. But we have our pattern now, and now what we're going to do is we're actually going to finish this sketch. We're going to hit our revolve tool, and we're going to select. Oh, I forgot one step. We need to go back to that sketch. So we're going to go to our timeline. We're going to right click on the last sketch that we did, or the most recent sketch. Hit edit sketch. So we're back editing this sketch, and I'm going to grab the line tool one more time, and we're going to create our half circles. So we have that reference made. And then we're going to grab our trim tool. And you can see that when I did this, it initially turned blue, but then it turned black again. And the reason that happened was because suddenly one of the objects, or not all of the objects in the pattern, were the same shape or the same object anymore. But once we made them all essentially the same, Fusion essentially redid the calculations in the background to figure out where all of these are again, and it still had all of the relevant information essentially. So it fully defined them, for lack of a better term. So now we can hit finish sketch, and now we can select our revolve tool. And from here, we're going to select these three patterns. And the axis of rotation we're going to select is not going to be one of these, but we're going to select that piece of construction geometry we made as the axis of rotation. And we do that, and we can cut all three of the pips simultaneously. So rather than doing three individual revolve operations, we did them all at the same time with one operation. Much more efficient way of approaching it. And from there, we can move on to doing we need to do 4, 5, and 6. So I'm just going to select, we'll select this opposite side here. And we're going to select this guy. We're going to create and here we're just going to essentially do a very similar thing, where we're going to create a pattern to create our 4 pips, but we're going to use a different trick to do it. Instead of creating a rectangular pattern, which might be the intuitive approach to doing this, there's actually a way that we can do this very quickly with the circular pattern. And so the first thing that I'm going to do is I am going to grab our circle tool. I'm going to find the center of our cube here, or this cube face. I'm going to make sure that construction geometry is active, and I'm going to draw a circle. It doesn't matter what size this circle is. We're purely using this as a reference. But since physical geometry will actually be referencing back to this, we do want to give it a dimension and fully define it so that it doesn't change there's no opportunity for it to involuntary change on its own when we don't intend it to, because that could mess with things later on in the model. So it's good practice that if you're using a piece of construction geometry to reference back to the location of a physical, of an actual feature or another important piece of regular geometry, that construction geometry should also be defined. So from here, I'm going to I'm going to grab our line tool one more time. We're also going to use some construction geometry, and I'm going to create uh, some lines. Actually, we're going to use the rectangle tool as construction geometry. So grab your rectangle tool. We're going to use 2 points, and we're going to say that this is 3 and 3 there. And the reason I've done that is that I'm going to use this point here to create the location of our pip. And we're going to say this is 3.5, just like all of the other pips that we've been making. And now we're actually going to use the circular pattern tool to to pattern this pip in these other 3 locations really quickly. And so what we're going to do, but before we get too far uh, into that, what we're going to do is we're actually going to create the entire half moon first that we are going to use. I'm going to cut away that half moon. So we have essentially our final profile that we're going to use, right? And what we're going to do is we're actually going to scoop this out entirely. So we're going to finish this sketch. We're going to go to our revolve tool. We're going to select our profile. We're going to select our axis, and we're going to complete that revolution operation. Now we're going to go back into sketches. We're going to select that sketch that's for the four-sided or the 4 value on the dice. We're going to um, make that sketch visible. And now we're going to go under create outside of the sketch tool. So just in the regular workspace, we're going to hit create. We're going to come down here to pattern. You can see that the pattern, this menu is shifted because we're not in the sketch menu. We're going to select circular pattern. And now this dialog box looks a little bit different. In the object type, we are going to select features. Once we do that, we're going to select the revolve feature that represents that pip. And then we're going to select our axis. When we're doing circular patterning, we need an axis that we will basically trace a circle around. And that's why we created this construction geometry circle. When we do that, you can see that we have these 3 locations here. If we add our quantity to 1 and I hit OK, you will see that we had all 4 pips show up. The reason that this is working is that the circular pattern tool is taking the quantity of the objects or features that we're patterning and then using that value to divide 360 degrees. And so if you have 4 things to pattern around 360 degrees, that means that each one of them is essentially going to be offset by 90 degrees from each other. And with that, we can rapidly create all 4 pips. And so here we accomplished creating all of these pips with essentially one revolve operation and one pattern operation, rather than creating individual revolve operations for all of these pips. So we're coming up on about 35 minutes. I think I'm actually going to leave like the tutorial here, and I've demonstrated the sketching. I've demonstrated revolve. I've demonstrated trim, extrudes, rectangular patterns, circular patterns, construction geometry. You guys can move through the rest of the dice project with that piece of information. The last thing I will demonstrate, because I think the technical drawing that you guys are working with utilizes chamfers on the edges of the dice. I will show you how to add chamfers to the dice very quickly. So in our regular solid modeling environment, we're going to go over to modify, and we're going to come down here and we're going to select the chamfer tool. And I'm going to orbit around this real quick, and I'm also going to make that sketch go away. So we're looking at a clean object. And all I'm going to do is that I'm going to come down here into our dice object. I'm going to go to open the bodies. I'm going to select body 1. Oh, we can't do that. Can we? There we go. Select edges and features. So here, if we drag and drop this right now, we can preview this. You can see that it's chamfering all of the edges that are on the cube, and that includes the pips, and we don't want that. So what we're going to do instead is I'm going to cancel this real quick, and I'm just going to open the tool again. And we're just going to select the individual edges that we want, and I am holding down Shift as I'm left clicking on all of these line segments. And Shift behaves, Shift for selecting, just if you hold it down, is a modifier key that will just continue to add things to your overall selection. And it works for faces and other objects and features. So now that we've selected all of those, we can, in this dialog box down here, we can say we want a chamfer of 1 millimeter. And we can see the preview of that. And we can hit OK. And then I'm also going to turn that sketch off again. And so that is those are really all of the tools necessary to complete modeling the dice project. If you guys have run into issues, reach out to me on Discord, or make sure you guys come to class next week, and we will be spending time in class working on this project. So I hope everybody has a good weekend, and I will see you guys the next time we meet in class. Take it easy.